Alright guys, this is Mr. Richer. I hope you can hear me. First video is on sequences. First one being an arithmetic sequence, second being a geometric sequence. We're going to go through 4 common questions, starting with the common difference for an arithmetic sequence. And it's arithmetic because we're adding 7 between each number. Pretty straightforward stuff. That's the common difference, so positive 7. If I want to write this as an explicit formula, this is the formula that gives us each term in terms of the number in the sequence. So in terms of n. So for example, this first term is 1. This second term is 2. The third term is 3, and so on. So a formula for that is going to look like this. It's an arithmetic sequence. Your formula is always going to look like mx plus b, but it's going to be in terms of n. Our common difference is like the slope. So the sequence goes up by 7 every time n goes up by 1. So our slope is 7. And our starting point, there's a couple ways to think of this. Our starting point is when n equals 0. So if I want to work backwards one step to where n equals 0, I would imagine there being a negative 9 there. So that's one way to write our explicit formula. Or, if you just want to use the terms that are given to you, we can change this to n minus 1 and use negative 2, the first term that we're given, as our starting point. So those are two forms of the explicit formula that both work. All right, so if I want to write this sum in summation notation, I need to do a little bit of work first. So my n's going to always start at 1, but I need to know what the highest value of n is. So I need to know what 117, the n value for 117. I can use my explicit formula that I just found, set it equal to 117, and solve for n, with 18. So n's going to go from 1 to 18 with my explicit formula plugged in there. There's summation notation. And the sum of the sequence, we need to use this formula. The number of terms, the first term plus the last term divided by 2. The number of terms is 18. The first term is negative 2. The last term is 117 divided by 2. We get 1,035. There we go. Pretty straightforward stuff. All right. Let's try a geometric sequence. Now this is geometric because between each term we're multiplying by negative 6. Notice that the sign changes each time, so it's negative 6. So that's our common ratio, negative 6. An explicit formula for a geometric sequence, unlike the last arithmetic sequence example, has an exponential form. All right, so again, I'm going to write this 2 ways. Let's see here. The starting value will be here, and the base of the exponent is going to be our common ratio. And I'm going to start with n minus 1. Now this one's not as straightforward, and this works, I should say, because when I plug in n equals 1, I want to get negative 1/3. If I plug in 1 for n, 1 minus 1 is 0, negative 6 to the 0 power is 1, times negative 1/3 is negative 1/3. So that works. If I wanted to work backwards, we haven't really done this, and just use n, the exponent, our starting, I'd have to work backwards one step and divide by negative 6 to be a positive 1/18. Both work. All right, summation notation. Similar to what we just did, we'll start at n equals 1. But we need to find out what's the n value for this last term. So I'm going to set my to set my explicit formula equal to that last term. Negative 559,872. And I'm going to give myself a little more space here. I'm going to have to do a little bit of work. All right, so I'm going to multiply. Solve this guy. I'm going to multiply by negative 3 to undo the negative 1/3. Yeah, I've got that. All right. And that gives us a positive 1679616. All right, big number. Now, how can I undo this exponent? I'm going to take the log of both sides. I'm going to take the natural log of both sides. And when I do that, I can bring this exponent down front. So we're going to have n minus 1 times natural log of negative 6 equals natural log of 1,679,616. Okay? So divide by, so to solve for n, I'm going to divide by natural log of negative 6. And then I'm going to add 1 to it to solve for n. Okay? Now here's the thing. We cannot take a log. We cannot take a log of a negative number. So to find our value of n, we're just going to pretend that that's a positive 6. And it's going to give us the same answer. It doesn't matter. For our purposes here, we're trying to find the value of n for this last term. If we just pretended that these were all plus signs, it would be the same value of n. Those plus signs don't change how many terms there are in the sequence. So for our purposes here, we're going to use positive 6. That allows us to get a value for n, and it turns out to be 9. So our summation notation goes from 1 to 9, and I'm going to plug in my explicit. Alright, sum of a sequence. Different formula for our geometric sequence here. It's going to be the starting value, so A1, and then 1 minus r to the n, all over 1 minus r. So that looks like this. 1 minus negative 6 to the 9th. And 1 minus negative 6. And you get a negative number, which is what I expected. 0.33. It's a decimal because our first term is 1/3. Our first term is 1/3, so I was kind of expecting to get a 0.33. And I was also expecting to get a negative number because the largest number in the sequence, the last one, is a negative number. It's going to make the sum of all those numbers negative. So there's 9 numbers there. We add them all up, and you get that number. Cool. Thank you.